Hello everyone, I'm back again with This Is My Architecture and we're gonna talk about mobile Wala S3 access monitoring using ML. So let's jump into the video.
Hello and welcome to this episode of This Is My Architecture. I'm Kapil and with me I have Hari from Mobile Wala. Hari, welcome to the show.
Thank you for having me, a couple.
Hari, can you tell us a little bit about Mobile Wala?
Sure. Mobile Wala is a consumer data and artificial intelligence company. We work with businesses, enterprises to understand, model, and predict customer behavior using data, which helps those companies to acquire, retain, and grow their customer base.
Okay, and Hari, a few months ago you adopted Amazon Elasticsearch service. Can you tell us what was the use case that you were trying to solve?
Sure. So, Mobile Wala being a data-centric company, so we have a lot of data exchange happening us between us and our customers. And our entire platform is residing on AWS, and we use S3 buckets as our primary mechanism to share data with each of our clients. So we wanted to build a proactive, near real-time anomaly detector system to look into the access logs and alert us if there is any suspicious activity, or to help us find if there is any compromised keys.
So what he's talking about, he's sharing uh, the data which is being created by his um, AI and making suggestions for the customers and all those things and using S3 buckets. And now he wants to access the S3 logs using Elasticsearch and process them and look for anomalies, like if someone is trying to hack it, different suspicious IP, multiple types of login attempts and all those kind of things he's looking for. Elasticsearch has always been one of my favorite for processing logs. um, I've worked with Elasticsearch, Logdash, and Kibana, which is ELK stack. Um, and it's pretty good. It's pretty amazing. It gives you a very nice interface with Kibana, and Elasticsearch is super fast compared to any other text search database I've used. So I've used even MongoDBs. There's a text search in MongoDB, but it's not that strong, I guess. There's Solar, which is built upon Apache Lucene, and then there is Elasticsearch. So Elasticsearch is being like one of the best for text search. Yeah, let's see what he has to say more.
So you needed a system that would alert you when access patterns to data changed, and you needed this to be almost in near real time. How did you implement this using Amazon Elasticsearch?
So we used S3 access logs, and with the Amazon Elasticsearch anomaly detector feature. The key is the anomaly detector feature, which was available in the Amazon Elasticsearch. So each of the client data sits on their individual bucket. So all the access triggers an access logs, which gets delivered into a dedicated access log bucket. So moment the log lands in this bucket, it triggers an lambda function. This lambda function looks into the access logs, passes through the values, extract the values, and converts them into a fields, which then inserts into the Elasticsearch. So this is where we have configured the anomaly.
So just to let you know, guys, we can set up a lot of Lambda functions on a lot of different kind of S3 operations, like adding, deleting, accessing, and all those things. And what he's doing right now is actually on addition of logs, he's triggering a Lambda function and processing the data, access logs, and then giving the data to Elasticsearch. And I think so then he's gonna run an anomaly detection feature of Elasticsearch.
Detector to look into these access log records for each client and learn from the access pattern, and which in turn helps us detect if there is any change in access pattern or change in the source country. This, if it detects something suspicious or if it finds an anomaly, it triggers an alert. We use AWS SNS to send us email notifications, which our service team receives, and they do an investigation to further check if there is any cause of concern and take necessary actions.
That's a really interesting implementation, Hari.
Yeah, that's actually a really interesting implementation, and it's pretty amazing. But I'm still um, I just want to understand like why he's using S3. Maybe because it's the accessing S3 would be so challenging for the clients, for his clients. He could have easily used different RDS clusters, but yeah, that would have been expensive. And but yeah, it really depends because you cannot perform operational database queries on S3. You need to load them in some kind of like analytical tool, like analytical service like Redshift or Athena and all those things, and then you can process it. But I don't know, like I'm just curious like why he's doing it, and I want it be difficult for the clients to process their data.
As you built this system, were there any challenges?
IP address field. It required. Yep, we did face some challenges. When the Elasticsearch anomaly detector was initially introduced, at that time the IP address is not supported, so the detector cannot work on IP address field. It requires a numeric field, and what we have is IP address from the access logs. So at the Lambda, we were using a geolocation database to map each IP addresses to a country, source country, and for each country we assigned a unique numeric ID, and we also add additional custom fields which we require later in our Elasticsearch anomaly detector configuration. So that field is the client name. All these fields are custom fields which the Lambda inserts into the Elasticsearch for each of the access log records. In the Elasticsearch, when we are configuring the detector, so we use the client name to filter out each client's access log separately, and we use the country ID which is converted from the IP address to a numeric value as the field for the detector to work on.
Hari, you have had this system running for several months now. Can you tell us a bit about the performance and the outcome so far?
So far, the system has functioned flawlessly. We receive close to 18 to 20 million access log records every month, and the system is able to pass through all them. It was able to learn from the access pattern. For each of the client, it was able to build a model, and it was able to detect any anomalies.
That's fantastic, Hari. And have you received any such anomaly detections so far?
Yep, we did receive a couple of them, and after investigation, it turned out to be a change in the access time, which the detector noticed from how it learned from the historical records, and that got we got an alert, and after we investigated, we recognized as a valid access.
Got it. So that's a very interesting implementation. And do you have any plans to extend this to other sources of data, perhaps?
Yep, we wanted to. So right now, only access logs are in this particular system. We wanted to see if we can bring our system metrics like CPU, memory, and disk metrics also into Elasticsearch and use anomaly detector to help us detect any spike in the system activities or any unusual behavior or unusual activity, and so that we can take actions faster.
That's
And that's something amazing. But yeah, of course he's talking about not the S3 buckets because there's no system CPUs or memory in S3, but I guess he's talking about his EC2 clusters or ECS clusters and EC2 instances, or maybe something like that. Uh,
fantastic. Hari, thanks a lot for sharing all these insights with our viewers. And thank you.
so yes, the architecture looks pretty good. I think so he's triggering emails to only himself, and then he's validating it instead of triggering to his clients. I think so he can do a client trigger to a client as well, but as he mentioned that most of the requests were valid. The only problem was the access time. It was a different access time. Usually we do it 8 a.m. in the morning, but now we are doing 12 p.m. in the morning for this particular client. So I think so that was the only anomaly he got, but so far it looks pretty good. um so thank you so much guys for watching this review, and if you really like the video then do give me a thumbs up and subscribe my channel.